वेलकम स्टूडेंट। आज हम देखेंगे महाराष्ट्र स्टेट बोर्ड 12th केमिस्ट्री प्रैक्टिकल सॉल्यूशंस और आज का हमारा एक्सपेरिमेंट है एक्सपेरिमेंट नंबर 2। सो लेट्स स्टार्ट। सो एम इज टू डिटरमाइन द concentration of in terms of molarity of KMnO4 by titrating it against a standard solution of ferrous ammonium sulfate, that is more salt. So here is the first question. The indicator used in redox titration is, and these are the options. So the correct option is option D, that is potassium permanganate. So all of you know that in the titration of KMnO4 versus ferrous ammonium sulfate, KMnO4 itself acts as indicator. So the correct option is option D. So next, select the titrant used in the redox titration, and these are the options for this question. So all of you know that during the titration between KMnO4 and FAS, KMnO4 is taken in the burette. So the titrant is option C, that is KMnO4. We know that the solution taken in the burette is called as titrant. So correct option is option C. So next, the oxidation state of Mn in KMnO4 in redox titration before titration is +7. The oxidation state of Mn after the completion of titration is, and these are the options for this question. So the correct option is option A, that is +2. So here is the explanation. In this reaction, the Mn from the KMnO4 has +7 oxidation state, which is then converted into MnSO4, and in MnSO4 it has +2 oxidation state. So the oxidation state of Mn after the completion of titration is +2. So next, the oxidation state of iron in more salt is +2. The oxidation state of iron after completion of titration is, and these are the options for this question. So the correct option is option C, that is +3. So here is the explanation for this question. So in more salt, iron is in +2 oxidation state. This iron is then form Fe2SO4 whole thrice. In this compound, the iron is in +3 oxidation state. It is ferric sulfate. So the correct option is option C. So next, the role of Mn2 plus ion during oxidation reduction titration of KMnO4 by oxalic acid is, and these are the options. So the correct option is option A, that is catalyst. So next are the short answer questions. First question is, what specific name is given to permanganate titration? So here the answer is redox titration or oxidation reduction titration. In permanganate titration, there are oxidation and reduction reaction take place, so the name is redox titration. Next, why heating is not required in ferrous ammonium sulfate and potassium permanganate titration? So the correct option answer is, the reaction between ferrous ammonium sulfate and potassium permanganate is very fast at room temperature. Hence, heating is not required in ferrous ammonium and potassium permanganate titration. Next, why dilute sulfuric acid is added while preparing a standard solution of more salt? So here is the answer. To prevent hydrolysis of ferrous ion, that is +2 ion, Fe +2 ion, and oxidation of Fe2 plus ion to Fe3 plus ion, dilute sulfuric acid is added while preparing a standard solution of more salt. So next question is, calculate molar mass of more salt. Given that molar mass of iron is 56 gram per mole, molar mass of sulfur is 32 gram per mole, molar mass of nitrogen is 14 gram per mole, and molar mass of hydrogen is 1 gram per mole, and molar mass of oxygen is 16 gram per mole. So we know that the molecular formula of more salt is FeSO4 in bracket NH4 whole twice SO4.6H2. In this formula there are 6 water of crystallization are present. So the molar mass of more salt is equal to 1 into molar mass of iron plus 2 into molar mass of sulfur plus 14 into molar mass of oxygen plus 2 into molar mass of nitrogen plus 20 into molar mass of H atom, because in this formula there are 1 iron atom is present, there are 2 sulfur atoms are present, there are 14 oxygen atoms are present, there are 2 nitrogen atoms are present, and there are 20 hydrogen atoms are present. So by substituting the values of molar masses of all these elements, we get this, and by doing the calculations, we get the molar mass of ferrous ammonium sulfate is 392 gram per mole. So this is the molar mass of more salt. So next, next question is calculate amount of ferrous ammonium sulfate required to prepare m by 20 standard solution of ferrous ammonium sulfate. So here is the answer. So we know that m by 20 ferrous ammonium sulfate solution means 0.05 molar ferrous ammonium sulfate solution, because 1 by 20 molar means 0.05 molar. So we calculate the amount of ferrous ammonium sulfate for 1 liter 0.05 molar FAS solution. So we know that the molar mass of ferrous ammonium sulfate is 392 gram. So for 1 molar ferrous ammonium sulfate we require 392 gram of ferrous ammonium sulfate. So thus for 0.05 molar ferrous ammonium sulfate, that is 1 by 20 molar ferrous ammonium sulfate, we require 392 divided by 20 gram of ferrous ammonium sulfate, that is 19.6 gram of ferrous ammonium sulfate. Because to get 0.05 molar we need to divide 1 by 20, so we also divide 392 by 20 to get desired. We can also calculate this amount by using the formula of molarity. So we know that molarity M is equal to moles divided by volume of solution in liter. So we know that number of moles are calculated by formula mass divided by molar mass. So the molarity M is equal to mass divided by molar mass into volume of solution. So we have molar mass of ferrous ammonium sulfate is equal to 392 gram per mole, and the molarity of ferrous ammonium sulfate solution is 0.05 molar, that is 0.05 moles per liter. So volume of ferrous ammonium sulfate solution is equal to 1 liter. We assume that the here volume is not given, so we assume that for 1 liter we have to calculate the amount of ferrous ammonium sulfate. So by substituting these values in the above formula, we get 0.05 molar 0.05 mole per liter is equal to mass divided by 392 gram per mole into 1 liter. This is the mass for ferrous ammonium sulfate. So by rearranging the equation, we get mass of ferrous ammonium sulfate is equal to 0.05 mole per liter into 392 gram per mole into 1 liter. So we get, by doing calculation, 19.6 gram. So this much amount of ferrous ammonium sulfate is required to prepare 0.05 molar solution of ferrous ammonium sulfate. So next, I think the question is over. So thank you. I hope you like the video. Thank you.